In this video, we're going to talk about irrational numbers. Now, irrational numbers are simply numbers which cannot be expressed in the terms a over b. Yes, cannot be expressed in this and in a fraction form, and a and b do not have common factors. So, knowing that irrational numbers really cannot be simplified or that kind of sense. So let me give an example of some irrational numbers. So some irrational numbers are, so examples of these numbers are for example square root of 2. So remember we said in the last video, we said rational numbers are decimals with repeating numbers. So example, we said 0.333 is rational. But for irrational, we're going to have numbers like 0 0.1, 2, 4, 5, 6, 8. You really cannot come up with something with a fraction version of this because it won't be accurate. So instead, what we do with our irrational numbers is, well, in your first year, you really can't do anything with them apart from proving that a number is not rational. So how do we do that? So these are questions you'll be asked. So for example, prove, let me type this down. Okay, prove, increase the font a little bit. Okay, so you could be asked to prove that that 1 over 2, that square root of 2 is not rational. Well, anything that is not rational is irrational. Anything that is not irrational is rational. So if you're told to, so the only thing you'll be given on irrational numbers is to just prove that they are not irrational, because you really can't do much with them. At least for rational numbers, you'll be told express this in a fraction form, find the numbers in between. So for rational numbers, these are basically how we're going to be doing it. So you have to prove that the number is not irrational. So in this way, we assume that, or first we say, yes, we assume, sorry. Okay, so we assume that let me write this down, that square root of 2 is rational, or it is rational. If it is rational, then it can be expressed in the form a over b, and b should not be equal to 0, and a and b are members of integers. So this content, we simplify it first. So we say square root of 2 is equal to a over b. So we let square root of 2 be equal to this. Okay, so when we square it, get rid of the square root. Okay, get rid of the square root. So we're going to have 2 is equal to a over b squared, which is equal to a squared over b squared. So we can, from here we make a the subject of the formula, okay, by multiplying 2 times b squared, which will give us 2b squared, which is equal to a squared. And now what we can get from this statement here, from this, is that a to the power 2 is divisible by 2, because we can also do this. We can as well do this. B squared is equal to a squared over 2 over 2. So we can say that a squared is divisible by 2. Now moving forward, we can say that a squared has a factor of 2. We just create some space. Squared has a factor 2. Now let's say, so we say that a, so we say that a is equal to 2r, or you can put 2b, 2c, to take note that r should be a real number. So now that we've got a is equal to 2r, remember what we said. We said a is equal to a squared is equal to b 2b squared. A squared is equal to 2b squared. So we can put, where there is a, we can put 2b squared. So 2b squared is equal to 2r. So we have to square this because everything we had on top was squared. Okay. Then we simplify it. 2b squared is equal to 4r squared. We divide this by 2. We divide this by 2. What we have is b squared is equal to 2r squared. 2r squared. Now again, what you notice here is that b squared is also divisible by 2. B squared is divisible by 2. Divisible by 2. Divisible by 2. So what we noticed about real numbers is that a over b, real numbers can be expressed in the form a over b, and b should not be equal to 0. Both a and b are members of integers, and a and b should not have common factors. That's what we said about rational numbers. That's what your general rest. That's what those are the properties of rational numbers. So what we've noticed here is that a is divisible by 2. a sorry, a is divisible by 2, and b is also divisible by 2. Hence, they have a common factor 2. A and b have a common factor 2, which is a contradiction because we said they shouldn't have a, if they are rational numbers, they shouldn't have a common factor, but in here they do, so meaning they are not rational numbers, and hence they are irrational numbers. So this method is called the method proving by contradiction. This is the main method we're using for proving for irrational numbers. So I'm going to do more examples in the next video. So bye.